Good morning, good afternoon, good evening, ladies and gentlemen. It is 11 o'clock in Geneva time, so I think we can start. Very warm welcome from Geneva to the Minamata online session 2, season 2. This is the third session of this season. As you see in the on the screen, it is quite small to see. But this second one in the science stream that we are organizing with the ICMGP International Conference on Mercury as a Global Pollutant, which is shown in yellow on the screen, and this calendar is on the Minamata Convention website. The next slide is a flyer that we shared with you, and the topic is Mercury in the Southern Hemisphere. And from the side of the Minamata Convention, we note that much of the scientific evidence for the development of this Minamata Convention came from the scientific knowledge in the Northern Hemisphere, including the Arctics. But we are very, very excited about learning from the recent progress in the Mercury science in the Southern Hemisphere. The next slide is about the logistics of today's session. And if you are calling in from WebEx, you are already you're automatically muted, and we may have time to invite some oral intervention. In each case, we may unmute some of you on the floor, but basically we are using the Q&A box for question and answers, and which only the panelists can see. Yeah, and also we may use the chat box if needed. So and also please note that the session is already recorded, and the presentations and the recording will be made available on the Minamata online website. We don't see many attendees here, and there may be some trouble because we recently changed the platform of our website, so there may be a bit of challenges for registered participants to call in, but I hope that we have more participants in the course of this session. So now I would like to invite Dr. Joylina, who is the co-chair of the ICMGP in South Africa.
Good morning, good evening, good afternoon, all participants, and also our presenters for today. As myself, the co-chair of the Mercury Conference, the International Conference on Mercury as a Global Pollutant. As you all probably know now already, the conference is happening on the 24th to the 29th of July 2022 next year. It's a virtual event, and the details can be found at that website below. The next slide, please. We also, this is the panel, not the panel, the executive committee of the conference. It's all on the website as well. We've just added more international ones who joined in 2021. Next slide, please. And then this is a very important slide. So we have a call for proposals, as well as a Lifetime Achievement Award, as well as an Emerging Researcher Award. That call that is closing on the 8th of October. And so the last one is the call for workshops, mini proposals and presenters. So so very much still open. If anyone is interested, please do go and visit the website and submit your either your call for proposals for the mini workshops, or your emerging researcher, nominate someone. There's criteria, or the Catherine Mahaffey Lifetime Achievement Award. And next slide, thank you. And then, as you know, it's work in progress for the face-to-face conference, which will then take place in Cape Town in July 2024. Thank you, Isako. That's all I'm going to share in the interest of time. Thank you.
Thank you, Joy. And then I would invite the chair, the conference chair of ICMGP, Lin Will, if his connection is sufficient, to start moderating the substantive session. Lin Will, would you be able to speak?
Okay, well, thanks, Isaku. Good morning, everybody. Good afternoon, good evening to those from the eastern part of the world, and those that will join us later, or that will watch this presentation later. We also welcome you. I know there's some challenges currently for people to log on. I've been getting some WhatsApp messages, so hopefully this will be sorted out in the next few minutes, and a lot of people then will be able to join us for this very important session. From my side, I'd just like to say thank you for everybody that's joining us. As Isako has mentioned, it's indeed, I think probably a first time in ICGMP history that there will be a session that will fully focus on the Southern Hemisphere. So we've definitely come far in terms of research, and today we definitely have a jam-packed program, if I can put it like that. So we've got 4 excellent speakers lined up for this morning, and I hope that you will enjoy the session with us. Just to give you a layout of the session, so we will start with a short introduction by Larissa, and then the speakers will then follow afterwards. So I'm just going to give a quick intro, and then Larissa, then I will give over to you. So our first speaker for this session that will focus on the Southern Hemisphere is Dr. Larissa Schneider. She's an environmental scientist with expertise on the use of lake sediments as a proxy to track sources and reconstruct historical mercury depositions in the environment. She did an MSc at the National Institute for Research in the Amazon in Brazil, where she grew up. And then she spent about 5 years in the Amazon studying mercury bioaccumulation in reptiles and in exposure to indigenous people. She then moved to Australia in 2009, where she undertook a PhD in ecochemistry at the University of Canberra, where she studied emissions and fate of toxic metals released by coal-fired power stations. She did a postdoc for about 4 years at the Australia National University, where she established the Mercury Australia network. The main aim of Mercury Australia, or this aim of the network, is to produce scientific information to support regulation and governance of mercury in the Southern Hemisphere, with a special emphasis on the Asia and the Pacific region. Currently, she's a research fellow at the Australian National University, working with isotope techniques to study mercury sources and deposition in Australasia. So it's my privilege, Larissa, to give you the floor this morning, or this evening in your case.
Thank you very much for the introduction, Will. Much appreciated. So I will share my slide here, my intro slide. Can everyone see my presentation? Yes.
Yes.
So I'd like to start our presentation thanking Isako and Joy for putting together this talk about Mercury in the Southern Hemisphere. It is our very pleasure to be here today with this diverse team of researchers working and based in the Southern Hemisphere. And so before we start, I'd like to note that this talk is actually a preliminary of our synthesis paper that will be presented in the 2022 ICMGP in Cape Town. And so, as I was saying, our group was really focusing on diversity to be able to build this project. And so we are mixing mid-career researchers like myself and senior researchers. And we hope then to produce a legacy of Mercury research in this side of the world and produce future researchers that will arise from this activity. And we also have a gender balance and authors from a wide range of countries. Like today we have Saul in Venezuela, Gian in Brazil, Jenny and myself in Australia, Lin Will from South Africa. So, and we have at least 5 native languages in our group, which is really interesting because we then are able to access great literature and all important literature that will base our project. So as you already realized, we have a big task ahead of us. So we chose a very big geographic area to study Mercury and to do our synthesis papers. So the way we started going about it was we met with researchers for each continent, and we brainstormed everything about Mercury that we knew on the sides of the world. And then we realized that geographic barrier wasn't really something feasible for this project. So we had to make second plans and restructure everything. So Jenny and I sat and discussed how to go about it. And now I'm going to hand it to Jenny, who is going to explain our planning to frame this project. Jenny, over to you.
Hey, Larissa. Yeah, so as Larissa said, it's a pretty big topic. We're still scoping out, so we're presenting kind of our plans today. So far, what we've decided is to limit the scope to the populated continents and regions. So we're not including Antarctica, except where it becomes relevant to some of the other pieces of the puzzle. And we are including the Northern Hemisphere tropics, where they're relevant and connected to the problems and issues that we're talking about, given kind of much of the importance of the tropics, as we'll see later. Our focus here is really on what's unique in the Southern Hemisphere, what makes it different from what we know about the Northern Hemisphere, and what that means for us understanding Mercury cycling on both local and global scales. And we're focusing on where the gaps are in the existing literature and what some of the future research needs are. And Larissa, if you want to jump to the next slide, please. So with that, the focus questions that we'll each be addressing in the different parts of our talk today are really those same key things. So what is unique in the Southern Hemisphere relative to the Northern Hemisphere, and what are the implications for Mercury cycling and our understanding? What data exists to inform our understanding of those differences, and where are the most important gaps? And each one of us will kind of cover each of these topics in our own way throughout our shorter presentations. And if you can just go to the next slide, please. So this figure really illustrates the organization of our talk today, which is also kind of the planned organization of the synthesis paper. We'll be starting out with Saul talking about the historical context for emissions and trade of Mercury. Moving on to me talking about the present day atmosphere, to Larissa, who will speak about the situation in land and water, and finally Gian, who will speak about the biota and exposure side of the problem. So that really sums up kind of where we're going today. I'll just turn it back to Lin Will to introduce the rest of the speakers, and then we'll go through the talks. Thanks.
Thanks, Jenny and Larissa. So I see there's still a lot of people struggling to get in, but hopefully if you are able to log in, just to give a quick recap. So we will be having the second Minamata online session today in terms of the science stream. that will focus on mercury in the Southern Hemisphere. And as Larissa and Jenny has alluded, that this forms part of the 4 synthesis papers for the ICMG GMP conference that will take place in next year in July, from the 24th till the 29th of July 2022. It will be a virtual conference. And so this session forms part of the synthesis papers. We as the executive committee have identified 4 synthesis papers. The first session was presented, which focused on climate change. This is the second session that will focus specifically on mercury in the Southern Hemisphere. There will be a session next month that will follow, that will focus on health. And then we will also have a 4th synthesis paper that will focus on ASGM. So the first speaker that will focus on his contribution towards the synthesis in the Southern Hemisphere is Saul Guerrero. And when I read his short CV, the first sentence really stood out for me, where he said he's a young historian at an advanced age. So I think that's very well put. So his research combined chemistry with history in order to study the environmental impact of mercury used from the 16th century to the 19th century. His area of research are global accounting for anthropogenic mercury emissions to the environment until the end of the 19th century. The use of mercury in Australia during the 19th century, together with Larissa, and the advances and useful and practical knowledge in metallurgy in the Upper Andes during the 16th century. At present, he is an invited fellow for the School of Language and History and Culture at the Australian National University. So I give over to you as our first speaker. Thanks.
Good morning, and thank you for joining me as we travel to the past, to the moment when it all began with respect to Legacy Mercury. Around 500 years ago, in the Republic of Venice, a patent was filed for the refining of silver ores using mercury. The process would only reach its true potential due to the discovery of major silver deposits in the Hispanic New World. The picture that we're seeing of the city of Potosi triggered, in fact, my interest in this topic, because for me it was very difficult to reconcile the fact that you could have a city of around, at its peak, of around 100,000 inhabitants, right next to the silver refining units that you see snaking to its right-hand side. That, according to interpretation at the time, was spewing hundreds of tons of mercury to the air, year after year, with no apparent health effects on the civilian population. The answer to this contradiction lies in the fact that mercury was a reagent in the process of refining silver. Mercury reduced silver chloride to elemental silver, which was then amalgamated, and in turn was converted into calomel, which is mercurous chloride. And if you look at the stoichiometry of the reaction plus the available historical data, it is possible to project that roughly 85% of all the mercury used for silver refining in the New World was converted into calomel. The remaining 15% was lost mainly as liquid mercury, and a very small percentage, probably less than 1%, was lost as volatile mercury to the air. One of the key messages of this presentation is that the sources of legacy mercury change over time. This is not a static scenario where one size fits all. The initial approach, if we want to quantify legacy mercury, is to look at the profile of mercury production over time. And it would be much easier if we could assume that everything that was extracted from the ground is legacy mercury, and it's simply a question of adding up production. Unfortunately, it isn't so. To make it slightly easier to analyze, I divide the whole production profile up to 1900 into two phases. The initial phase until 1850 is definitely defined by the refining of silver ores in the Hispanic New World. The second phase from 1850 onwards sometimes has been associated with the California gold rush, but this is not strictly correct. And as I will try to demonstrate in the following slides, there were other more important factors at play. On this curve, I have drawn red and green arrows. The red arrows imply that there are forces at work that could increase the amount of legacy mercury beyond the levels of registered production. The green arrows are the forces that would tend to decrease legacy mercury. The red arrows are basically the additional losses of mercury incurred during the smelting of cinnabar, and these could be substantial depending on the equipment used. The green forces are the sequestering of mercury, let us say, either in calomel or in other end products. In the first period up to, say, the middle of the 19th century, it is very clear-cut. The supply chain, there are three main sources. The largest one has always been Almaden in Spain. Idria has always been an important historical and early source in modern-day Slovenia, and Huancavelica in South America. The mercury produced in these three smelting sites was destined basically to New Spain, Mexico, modern-day Mexico, and to Peru. As expected, the end used for all this mercury was the refining of silver ores in the American continent, and of the anthropogenic emissions, roughly 60% would have taken place in the Northern Hemisphere and roughly 40% in the Southern Hemisphere. From 1850 to 1900, the whole picture changes. It's a completely new ball game. Now we have these arrows of mercury supply spanning the whole world, and the first impression could be, well, it's simply that there are more countries refining silver or extracting gold. But no, that isn't the explanation. You have China coming up as a major importer of mercury. Europe, countries in Europe like France, Holland, Belgium, Germany also become major users of mercury. And so we now have a changed global market for this product, and therefore for the sources of legacy mercury. I have represented in red the consumption of mercury by countries who do not show major production of primary silver or gold, and in blue those that do. And you can see that the global market now is basically shared between the more traditional use of mercury to refine silver and gold, with the use of mercury to produce vermilion, which is a red pigment used in lacquerware or paintings, mercury fulminate, which has a military use in blasting caps. And those who saw Breaking Bad, the series, you would have seen the explosive nature of mercury fulminate, and also for medicines. The reality of the new global marketplace for mercury is reflected in the distribution of anthropogenic emissions between the hemispheres. Approximately 85% of those emissions would have taken place in the Northern Hemisphere, and only about 15% of those emissions in the Southern Hemisphere. Now you will have observed I have not included figures, specific data, but the visual segmentation is a good reflection of the information we have at hand at the moment. The fact that we still do not have consensus on the amount of legacy mercury is a reflection on the gaps in our current knowledge. Though we know calomel was formed, we do not know what its life cycle is in the soil. Though we know that mercury is lost during the smelting of cinnabar, the historical record, unfortunately, is pretty hard to crack, since they did not measure the amount of mercury in the cinnabar ore, which makes it very difficult to estimate how much was lost. In spite of all this, and to end on a positive note, we have made progress. And as historians continue to work together with environmental scientists, more and better questions will arise in the search for a more discerning picture. We need to recognize that legacy mercury is not a single homogeneous entity, but the sum total of many sources that are time and location specific. I hope this presentation will help to stimulate further multidisciplinary efforts in this regard. Many thanks for your time.
Thank you, Saul, for that section. You definitely took us back into history. But this section just always just highlighted the importance of taking legacy mercury and what happened centuries ago into account, because as you've mentioned, the mercury that was used in those days did not magically disappear. It somehow circulated, and somehow we are still seeing and experience the effects of those happenings through those gold rushes. So in terms of how the Southern Hemisphere paper, or the idea that we have is layout, is that one section will then focus on this part which Saul presented. The second section will definitely focus on mercury in the Southern Hemisphere. And it's my privilege to introduce our next speaker to you in the person of Jenny Fisher. She says she grew up in Northwest California, and I've lived in LA, DC, Boston, Grenoble, London, and now she's based in France. So she's definitely traveled all around the world, just like the mercury in the atmosphere. So that's a good description. She started studies at planetary science at Caltech, and which she finished in 2005. Then she spent some time in Washington, D.C. the Geoscience and Public Policy intern at the American Geoscience Institute. She then enrolled for a PhD at Harvard in the planetary science, and she graduated there in 2011. And if I'm not mistaken, Daniel Jacobner was your supervisor. I'm not sure, but I think so, yeah. But in any case, and then she moved to Australia in 2012 as a Vice Chancellor, postdoctoral fellow at the University of Wollongong. And she's been there ever since. She's currently Associate Professor in the Center for Atmospheric Chemistry in the School of Earth, Atmospheric and Life Sciences. Jenny, over to you. Thank you.
Thank you very much, Lin-Will. And hopefully now everyone's seen my screen. So yeah, I want to pick up from where Saul left off and talk about the present day atmosphere, which is going to be the second section of our synthesis paper. And I'd like to thank a number of co-authors from across the Southern Hemisphere, as you can see here. I wanted to start by showing the Global Atmospheric Mercury Observing System, or at least the long-term monitoring system. This is a figure from the Global Mercury Assessment 2018 that came out recently that shows all of the air monitoring sites for Mercury that have at least a 10-year time series. And I've made a couple of modifications, including adding the Cape Grim station in Australia that's reached a 10-year milestone this year. And we have other data. We have other atmospheric monitoring, short-term campaigns, and some new things that are coming out now that I'll start to talk about. But this long-term record is really quite important for kind of thinking about what we think we know about the atmosphere now. It's given us a lot of our current information, and in particular, one of the things that it's established is this concentration gradient in the amount of mercury in air between the northern and southern hemisphere, which you can see in the boxes on the left-hand side here. However, there are some biases in our observing system, at least in this long-term system. As you can see, most of the sites are concentrated in the northern hemisphere. And the sites that we do have in the southern hemisphere are almost exclusively in the mid-latitudes, with the exception of Manaus in Brazil and the more recent Gun Point site. And almost all of these are coastal ocean influence sites, which impacts kind of what we think we know about Mercury at this stage. Concerningly, in recent years, we've lost some of these sites. So both of our South American sites are not currently operating due to a lack of resourcing. And like I say, there are some regional and passive networks that are starting to fill these gaps, and I'll come back to this a little bit later at the end of the talk. But the reason that I wanted to start with that map is that the observational gap really matters for what we understand here, because the mercury sources and sinks are different in the southern and northern hemispheres due to differences of geography, population, and the different sources that I'll talk about now. So probably the first thing that comes to mind when we talk about mercury sources to the atmosphere in the southern hemisphere is artisanal and small-scale gold mining, or ASGM. And the importance of this in this hemisphere is really illustrated by this figure from Steenhuisen and Wilson, which shows the mercury emissions, estimated mercury emissions as a function of latitude, going from the North Pole on the left to the South Pole on the right. And the darker gray-green bars are the non-ASGM emissions, and the light green bars are the ASGM emissions. And as you can see in this kind of figure, more than 2/3 of the emissions to the atmosphere in the southern hemisphere are thought to be from ASGM, and almost all of the ASGM emissions are in the southern hemisphere or in the nearby tropics. However, these emissions are really uncertain. We know they're important, but we don't actually have very good constraints on what they are. And in fact, the whole next ICMGP Minamata online session will be all about ASGM. So we're just touching on it briefly here. But I want to highlight that our long-term observing system may not be sufficient currently to constrain these estimates. And if I put this map up that is our map of where we think these emissions are coming from, and superimpose those long-term monitoring sites that we still have running, you can see that they don't really overlap to a large extent with where the ASGM emissions are thought to be. And we've got some particular gaps in Africa and Indonesia. Another important source of mercury emissions to the atmosphere is from fire. And both natural wildfires and slash and burn agriculture are really prevalent in the southern hemisphere. And if we look at metrics like the amount of area burned, which is what's shown in the figure here, or carbon emissions, we find that the majority of global emissions are in the Southern Hemisphere. And we could expect the same may be true for mercury, but of course that will depend on the amount of mercury in the things that are burning. And we have seen elevated mercury in fire smoke at sites across the Southern Hemisphere in all sorts of different environments with different monitoring sites. So we know that it's important, but being able to constrain the actual magnitude of that really depends on us having some local knowledge of those fires, being able to measure the emission factor or the amount of mercury that's emitted when something burns. And that will in turn depend on the mercury content in the vegetation and soil, which means we need to understand unique ecosystems in this part of the world. And we also need to understand that legacy mercury that Saul's been talking about and how much of it has been deposited to these ecosystems over time. And Larissa will touch on this as well. Another feature of the Southern Hemisphere that makes it quite unique from the Northern Hemisphere is the distribution of ocean versus land. And the Southern Hemisphere is about 80% ocean area, which is quite a lot more than the Northern Hemisphere. And the ocean is especially important if we're not considering the Antarctic continent, as we're not thinking about in this paper. And as I pointed out earlier, most of our observations are coastal. So we do have some pretty good data to support the importance of the ocean as a source of mercury to the atmosphere. And this is also seen in our models. And an illustration of that is shown in these figures here, which shows some of the data from the Cape Point station, with on the left areas that are sources shown in red, and on the right areas that are sinks shown in blue. And we see the importance of the nearby ocean as a source for mercury and the land as a sink. And in fact, there's quite a lot of work that suggests that the land is a sink for mercury, especially in heavily vegetated regions. And some estimates suggest that up to 70% of the mercury that's deposited via dry deposition and vegetation uptake could be deposited in the Southern Hemisphere tropical and subtropical forests. In particular, very large tropical forests in the Amazon and Indonesia and Papua New Guinea. Now, there are some good data for the Amazon to support this. The data for Indonesia and PNG are lacking, and that makes it a bit harder to really constrain the magnitude of that large forest sink. And also leaves questions open about the impacts of deforestation, because in addition to impacts on the land and water that Larissa will talk about, and impacts from deforestation due to burning, so some of that mercury being emitted in smoke, we also are, by deforesting, losing some of that land carbon sink, and that's going to have an impact on the overall mercury budgets in the atmosphere. Another source we need to consider are fossil fuel emissions and trends in those. And when we think of global biogeochemical cycling of mercury, we often think of the clean Southern Hemisphere because of the lower overall population and the lower non-HGM emissions. But of course, we have some very large urban and industrial areas across the Southern Hemisphere. And in urban and industrialized locations, the observed mercury is really on par with similar regions in the Northern Hemisphere. And there are also other sources we need to consider, such as the elevated mercury that's been observed associated with domestic coal combustion. So in the South Africa Highveld, for example, people burning coal at home for home heating, as well as sources from domestic waste burning, which are prevalent in some parts of the Southern Hemisphere and are a really uncertain source. And importantly, if we think about projected trends in things like population growth, urbanization, industrialization, and regulation, all of these things differ from what they look like in the Northern Hemisphere. So we can expect differences in the trends in mercury in the atmosphere, but currently our observational records are too short to be able to statistically or reliably capture any trends. And finally, I want to speak briefly about legacy emissions and the impacts on present day concentrations in the atmosphere. So a recent paper by Lee et al. That came out last year showed that if you look at the sediment records, there's a bigger historical mercury increase from the sort of pre-anthropogenic period through to the 20th century. That increase is a lot larger in the Northern Hemisphere than it is in the Southern Hemisphere. And of course, part of that is due to the lower anthropogenic emissions and perhaps some of the issues that Saul has been talking about. But in addition, there's an implication from that paper that the natural background in the Southern Hemisphere, so the impact of the natural background without any anthropogenic emissions may be higher in the Southern Hemisphere than in the Northern Hemisphere. And that's been related to the larger ocean area and the importance of an ocean source, as well as perhaps less terrestrial vegetation uptake. But of course, that understanding is dependent on our understanding of the present day mercury atmospheric concentrations that I showed on the previous slide, which again have largely come from these mid-latitude coastal sites. And so there may be some sampling bias here in trying to understand what the current mercury concentrations in air actually look like in natural regions of the Southern Hemisphere. And in fact, some newer measurements in the Southern Hemisphere, including in the Patagonia region of South America, as well as in Australia, show that at our inland sites, ambient mercury is actually quite a lot lower than at some of the coastal sites, up to 70% of what we see at the coastal sites. So there are still some really big unknowns about what's going on when we move away from the coasts and away from the major sources. So that brings me to the key gaps in research needs for this part of the story. First of all, we need consistent and ongoing measurements to really be able to do trend analysis. We know the atmosphere responds pretty rapidly to changes in emissions, so being able to have those consistent measurements to tell us what's happening there is really important. We have big data gaps from the tropics, especially Indonesia, PNG region, but also in Africa and increasingly in the Amazon as we lose some of the South American stations. We need constraints on emissions from ASGM sources, as well as from fires in Southern Hemisphere ecosystems. And really, I think we really need a diversity of types and locations of Southern Hemisphere air measurements so that we can start to disaggregate these different influences of things like, is it a coastal versus inland site? Is it near source or remote? How meteorology and climate patterns vary and influence the mercury. And so we can distinguish all of that from the true latitudinal variability and the Northern versus Southern Hemisphere effects. And just to end us on a positive note here, we do have some big gaps, but there's a lot of effort going on globally for regional networks and some passive sampling to start closing these gaps. And these are just a couple of examples of some new regional wet deposition site in Indonesia, some recently established passive monitoring sites across, and some active monitoring sites across Africa, and some proposed sites in South America. So I think we've got a long way to go, but we're starting to make some progress there. So I'll end it there. Thank you very much.
Okay, thanks, Jenny, for that interesting information and that interesting presentation. And it's always good to end on a high note. So, I mean, we are definitely, as researchers in the Southern Hemisphere, we are definitely acknowledging that there are several gaps. And I think through this collaboration and this new partnership, we will definitely be able to fill in all those gaps, be it by passive sampling or by instrumentation, but at least we're moving in the right direction. It's good to know that I just checked on the YouTube channel, so there's about 40 people that's watching live. Just again, apologies from our side in terms of the technical challenges we've been experiencing today with the login, but at least you are able to watch us on YouTube. And some of the researchers that do have my WhatsApp details, please send a question or use the Twitter handle of the Minamata Online or the Minamata Convention. We will definitely try and see when we get to the Q&A section if we can answer some of your questions, because it's going to be a bit boring just having a Q&A with all the panelists that need to speak with one another. So hopefully more people will be able to join us. So in terms of the structure, so that was the area that focused on air. The second section, or the third section, will focus on land and soil. And Larissa will do her presentation for us. Again, thank you, Larissa.
Thank you, Lin-Will. Let me share my screen here. Are you able to see my presentation?
Yes, we are able to see it.
Yes, thank you so much again, Lin-Will. for passing it on. So I'll be talking about Mercury in the Southern Hemisphere in relation to land and water. So I'd like to start my presentation by thanking my colleagues, Ana-Helene Forstier, Jean Guimarães, Chavon Walters, and Maria Diegues. They have been very important in discussing ideas and the topic that is related to this presentation, particularly to Ana-Helene Forstier, because she's shared some of the visual aids that you're gonna be seeing today. Thank you so much for my colleagues. So when I was building this presentation or working on this presentation, I was thinking about what are the particularities of Mercury in the Southern Hemisphere, of the cycle of the Mercury in the Southern Hemisphere, that are unique in relation to the Northern Hemisphere. And I realized that these particularities are very linked to ecosystem, economics, and culture of the Southern Hemisphere. So based on that, I based my presentation on these 5 factors here that direct affect the Mercury cycle in our hemisphere, and I'll be talking about them. So ecosystem. Perhaps the best example that we have of a very particular ecosystem in the Southern Hemisphere is the Amazon. So starting with the fact that in the last glacial maximum, while the Northern Hemisphere was under ice, the Amazon was having dew nights and receiving mercury deposition and uptaking mercury through forest as per normal. And so the last glacial maximum was a period in which the Southern Hemisphere, specifically the Amazon, had way more opportunities to uptake mercury than the Northern Hemisphere. And as a result, we have very high mercury concentrations in the Amazonian soil as naturally occurring, not necessarily because of anthropogenic activities. So I have here a scheme of the Rio Negro Basin in the Amazon to show to you more or less how this budget of mercury happens over there. So basically, the input of mercury in the system occurs via dry deposition, wet deposition, leader fall, and through fall. So together, these components, they make up to 42 tons of mercury deposited in the Rio Negro Basin, only in one basin of the Amazon, per year. So it's a lot of mercury. And in this particular study of Silva et al. 2009, they even didn't predict a dry deposition in free fall. So it's actually a little bit underestimated. And then the output of mercury is via fluvial draining and water emissions via the water atmosphere interface reactions, and soil emissions by the forested areas, which I'll be talking about a little bit later. And so this output accounts for about 2.6 tons of mercury per year. So in general, overall, the Rio Negro Basin is retaining about 40 tons of mercury per year. So, and we also know that the Papua New Guinea soils have similar concentrations to the Amazon, but we don't know much about it. So Ana-Helene Forstier and Jean Guimarães and other people that I'll be talking about during the presentation have done like extensive work in the Amazon, mainly sparked by the gold mining period there. And now we have good results that talk about, how the ecosystem and the dynamics of the ecosystem influences mercury cycle. But we don't know much about Southeast Asia, for example, and Africa, which have lower emissions, and well, Australia and Africa have lower emissions, and I'll talk about later. So Ana-Helene Forstier has done extensive work to understand very well how the forest uptakes the mercury. So as Jenny was saying, most of the mercury in the atmosphere is in the elemental form. And what happens is the canopy of the forest has a large surface area because of the leaves. And through the stomates, these leaves are able to trap this mercury from the atmosphere. And then through leader fall, this mercury ends up in the ground. And because the Amazon is a very humid and hot environment, this organic material in the ground breaks down very quickly and mineralizes. So most of the mercury actually is not in the organic part of the soil, which is very thin in the Amazon, but it's in this orange 2.5 meter, more or less, part of the horizon, soil horizon, which is the horizon B. And because it has a lot of iron and aluminum oxyhydroxide that will work as a sponge to absorb the mercury from this organic matter inwards in the soil. And that accounts, so that the amount of mercury in the Amazon accounts to 3 times more than what we usually find for temperate forests. And so after Anne Fostier has done her work in the Amazon, Wang et al., they extrapolated her work to a global view. And through modeling and mathematical statistics, they have estimated that the global mercury deposition through litter fall is about 1,180 tons per year globally, being that from this total, 23 of the deposition happens in the Amazon. But as you can see here in this image on your right side, there is quite a lot of a red mark, like showing high deposition of litter fall in Indonesia, in Southeast Asia. But as the author pointed, we don't have enough information to make a good conclusion of how much deposition is happening there. So the estimates over there is not very precise, which is something that we have to work on. And so just to give some perspective on these high concentrations of mercury in the soil in the Amazon, I'm showing here some concentrations of mercury in sediment, aquatic sediments of Australia and South Africa. So what I want to show here in the map of South Africa is that Chevron Waters has done a lot of sampling, spatial sampling around the country. Most of the sediment showed a concentration of less than 10 nanograms per gram. So in the Amazon, we find numbers above 100. And so in the region of Pretoria and Johannesburg, which is where these green points are, so you have concentrations no more than 100 nanograms per grams, even though it's a very industrialized area with coal-fired power stations. And in this area, a little bit to the right of Johannesburg and Pretoria, you find a region of ASGM, which has concentrations which are actually high and above 200 nanograms per grams. And then here on your left, it's just an example of a study that we had done here in the Amazon, in Australia. And the concentrations in sediments is in around 10 nanograms per gram, so that's the background. And so in soil, we know that the concentrations are around 20 and 40 nanograms per gram. So it's much lower than in the Amazon and in tropical areas. And I also wanted to show that we deviate from background, like we increase mercury depositions, atmospheric depositions at around 1950, which is the time of the Great Acceleration. While in the Northern Hemisphere, we see an increase in mercury linked to the beginning of Industrial Revolution, which is earlier in the previous century. So 2 is deforestation. So as I just mentioned that there is so much mercury in the soils of the Amazon, as you can imagine, deforestation is a very good way to mobilize this mercury and move it to the aquatic environment, which can be quite a good concern in terms of aquatic pollution. So Anne Fostier did a work on the top 10 centimeters of mercury in the Amazon of the soil. And she found that in natural areas, there is way more mercury than deforested soils. However, when she measured mercury in the water column downstream of these 2 areas, she found the other way around. She found less mercury downstream natural areas and higher, like 3 times higher mercury in the water column draining from the forested area. So just showing how intensive leaching and erosion transport a lot of mercury from soil to aquatic bodies, which then can be changed or transformed to methyl mercury, which then will be uptaken by food webs. Another activity that's very typical of the Southern Hemisphere, as mentioned by Jenny, is slash and burn agriculture. Though deforestation is more caused by large-scale agriculture, while slash and burn agriculture is a type of activity that's done by small farmers and traditional communities. So basically what they do is just they cut a block of land in the middle of the forest, and then the leftover of the biomass they burn to create ash, which is like a principle very efficient way to fertilize the land for planting. So this ash is rich in nutrients, and it's quite fertile for this cation depleted soil, which needs some nutrients to be able to grow good plants and make good crops. However, it's a bit of an illusion because this ash doesn't stay stable in the soil. So with a lot of precipitation, which is very common in tropical areas, all this ash will be washed to the aquatic bodies, which then will be moving all this mercury to rivers. The other thing as well is most of the mercury in the organic part of the soil, which is the top part of the soil, will end up going to the atmosphere. But then the big pool of mercury, which is in the mineral horizon of soils in the Amazon, will be exposed, and then through erosion and leaching can be transported to the aquatic environments. So it's a very effective way of contaminating aquatic environments. And there's also the formation of black carbon in these areas, which absorb a lot of mercury. It's reactive and absorb mercury from the atmosphere. And so what we know is about the Amazon, we have no information so far in Australasia and Africa. We need to kind of integrate these studies with mercury in ecology to know more about it. So small-scale artisanal gold mining, I won't touch much here. As Jenny said, there is a specific synthesis paper about it. What I just want to show here is that the mercury emitted in soils and aquatic bodies from ASTM is much more significant than the amount of mercury that goes to the atmosphere. We still have to do more studies to refine these figures, but we know that there is a lot of local contamination in both soil and aquatic bodies. And it's very typical activities of the developing countries. So, for example, in Brazil, where there is no good unemployment benefits, there's way more miners working than in French Guianas, where the French government help people with unemployment benefits. So, and even when you go to the Guianas, the French Guianas, some of the workers there are actually from Brazil. So it's a very typical activity of the developing countries and in the tropics. And what we're going to touch in the synthesis paper in relation to the ASTM for this compartment, land and water, is the hydrological conditions, how they influence mercury transport via suspended particles, and how much of this mercury is methylated and end up being uptaken by food webs. Another very particular sector of the Southern Hemisphere is the recent colonization of some of the places. A good example is Australia, who was colonized by the British at the end of the 1700s. And this is coeval with the start of the Industrial Revolution in the Northern Hemisphere. So as you can imagine, the empire was seeking for a lot of mineral resources from the colony in order to boost the Industrial Revolution. So just an example here, we have Mount Lyell in Tasmania. So that Mount Lyell was the largest copper mine in the Southern Hemisphere in the 20th century. As you can see in the image here, it's a very degraded area. It looks like a moon landscape, and it used to be covered in forest. And the interesting thing here is that this colonization brought lots of machinery because it was quite modern because of the Industrial Revolution. However, it was before the time that Environmental Protection Acts were in place. So the emission of metals, including mercury, was pretty much willy-nilly and has affected quite a lot this area. I also want to highlight here the use of mercury pesticide in Australia that was phased out just this year. As long as I know, is the last country in the world that phased out the use of pesticide, mercury pesticide. It's not related to colonization, but I just want to point it out here, this unique characteristic that, or particularity of mercury in Australia, because Australia was emitting 5,000 liters of mercury per year of organic mercury in the environment. And the reasons why this happened until 2021 is very political, but I wanted to illustrate it here. Timor-Leste also was became independent from Indonesia in 2002, and so it was only in 2016 that it had the first mining code put in place. So that's another thing that affected a lot the emissions of metals, including mercury, that has to be considered as well for the Southern Hemisphere when we talk about the cycle of mercury. And the other thing is like lack of law enforcement. So something very typical of some countries like Brazil and Indonesia, where mercury, it's illegal to mine gold using mercury, but it's an activity that the government hasn't still successfully phased out yet. And in general, the Southern Hemisphere had a later and less significant industrialization than the Northern Hemisphere, which should be taken account when considering land and water. So here are my significant gaps for the moment, but as mentioned, it's still a work in progress. Something that we have to do is do more measurements of mercury in soils in the Southern Hemisphere to understand exactly what is the natural background concentrations and by how much we deviated from what is natural. We also need to know the fates of the mercury releases from these rich mercury soils and how much is turned into methyl mercury and being uptaken by food webs. We need to understand also more about the ASGM emissions and fates. We need to know about bushfires, as Jenny was saying, something that happens quite a lot, like in Australia and Africa, and we don't know yet much, well, any information, as long as I know here in Australia at least. Mercury deposition in Southeast Asia and uptake by rainforests. So the work that Anne Fostier and Jean Guimarães have conducted in the Amazon would be very, very needed for Southeast Asia, where there are so rich tropical forests. And for the entire of the Southeast Asia or the Southern Hemisphere, actually, we need to develop a good mercury isotopic library to be able to pinpoint the sources of mercury in this side of the world. Thank you so much. I would like now to hand it back to Ling Will.
Thank you, Larissa, for that thorough overview and also just highlighting, I think, the important work that has been done by our colleagues from South America in terms of the studies that they've did in the Amazon over the past few years. Our last presenter for the day is Jean-Remy David Guimarães. He says he's a biologist, but currently he's a biochemist. So that's a link for him. Was born in 1955 and is currently professor at the Instituto de Biofísica Carlos Chagas Filho, Federal University of Rio de Janeiro in Brazil. He graduated after graduation in 1917 and with the MSc in 1982. He worked for 10 years at the Brazilian Nuclear Energy Commission on radiology and radiological environmental monitoring of nuclear plants. He entered UFRJ in 1993 and he started working on mercury in the Amazon using radio tracers to investigate mercury methylation sites and factors and highlighting the role of floating meadows and flooded soils in methyl mercury production. He's also focusing on mercury isotopes, and for the past 12 years, he's been the local coordinator of the Long Carrizo project in the Tapos Basin, funded by ADRC in Canada, the most extensive mercury project so far in the Amazon. Jean-Remy, I give over to you.
Thank you, Lingo. I will try to share my presentation. Are you seeing the presentation correctly?
No, John. I think you see the share tab on your screen. No, we didn't test it before, but you should be able to share.
Well, it says sharing content, connecting.
Yes, yes. In my screen, it just says share, but perhaps sharing content
Now it says
work.
choose
If
what.
yeah, if you go at the top, you have file, edit, and share. And then if you share, you have share content. Can you see that?
Yes, there is three choices of what to share, but
Yeah, so then you choose the PowerPoint slide that you have. And then at the bottom, there is another share that we have to click.
the problem is that he says he's connecting, sharing content, connecting, and this is.
Do you want me to run for you from here, and then you just say next when it needs to be changed?
I think it will be useful. Thank you, Larissa. You're saving.
Okay, I'll do that then. Can you see?
Yes, not the screen mode, but
Yes,
we see.
That's right. I can see it. Good.
Yeah, just say next, and I'll change it for you.
Okay.
Larissa, can you make it a full screen because it's
well, it is a full screen for me. I think that the sides of this slide, maybe if Cheerful can make it full screen, because I think it's not fitting my computer.
Well, I'm seeing the first slide of the presentation.
See the presenter view, Larissa. We just see the, yeah.
perfect.
There.
Okay.
Yes.
So, may I start?
Yes, please.
Well, good morning to all. Thank you, Lin-Will, for this nice introduction. And it's a pleasure to be here to talk to you today about Mercury in Biota in the Southern Hemisphere. Collaboration of this presentation this morning. Next slide, please. So some important Amazon specific features related to Mercury is that the first research was done in reaction to the gold rush in the 80s. And when the first paper was published, gold mining was about collapsed 2 years later. There was also a societal previous verdict about ASGM as main resource. This is what everybody wanted to hear at that time. And it was legitimized by the early scientific reports. There is a huge biogeochemical diversity in addition to biodiversity itself. You have black, clear, and white water basins, and in each of these, mercury behavior. The annual flood dose is very important too, with water varying up to 31 meters from dry season to wet season. So you can imagine the amount of land is flooded. The mercury data on fish are very discontinuous and fragmented, partly because of this high fish biodiversity. And anyway, we have long and complex food chains, which leads to high mercury concentration, and the perfect storm between this and high fish consumption, leading to high human exposure. It's a difficult area to study. If you go there, you will use modern vehicles, state-of-the-art anti-UV equipment, and the hotel, well, let's forget the whole next piece. So fasten your seatbelts, trying to summarize 30 years of mercury studies in the Amazon in one single slide. So the first studies were in reaction to the gold rush, and so they were done in basins with active ASGM. And they found high mercury all over high mercury levels in fish and also in human hair. That so fish close to 4 ppm, quite high, and mercury in human hair up to 50. On the other side, the ASGM emissions were estimated at that time to be 100 tons per year scale of the whole Amazon. So it seemed logical to assume one thing was the cause of Biota. And anyway, it was what society wanted to hear at that time, by the way. But there was a narrative shift in the mid-50s with the accumulation of data, of course. And so main source, initially gold mining, but then they started to realize it would be caused by man-induced acceleration of natural soil erosion by agriculture and deforestation, which is and it has different, very different policy implications if you think something. Another issue was the importance of biogeochemical factors. So Forsberg in '98, a classical, it showed in the Rio Negro Black River water the highest mercury levels in fish and human hair published to date at that time. This was not correlated to ASGM because ASGM was simply absent from the basin. It was correlated to water pH and VOC. So this was a nice big crack in the building of the initial narrative, and the next big crack was a series of work by Ogle and others in the Tapajos Basin, but they chose to work well downstream ASGM areas, and they started looking for mercury gradients, downstream mercury gradients in water or suspended sediments. They were never found. Same thing for fish, mercury in fish. What they did find were very, very high mercury gradients in local soils, 1 order of magnitude higher than in ocean soils. And they found a recent mercury enrichment in sediment records. Bingo. Well, the problem is that this enrichment started something like 20 to 30 years before the onset of ASGM in the region. They also found that in sediments, mercury was covariating with lignin, which is the component you find in terrestrial trees, so it is a marker of deforestation. So mercury in sediments covariating with the marker of deforestation. Quite suggestive. Next, please. So if we're discussing the relative importance of mercury sources, recently stable mercury isotopic ratios have been used successfully to that end. This requires that the isotopic signature of your source of mercury trace is different from the signature from the ambient mercury. This condition holds in the 2 sites where it was used so far, one in Brazilian Amapá in the Amazon and one in the Andes in the south of Ecuador. In one case, a big watershed with a small mercury signal, which is one single ASGM site. And what we see there confirms what has been shown in the last work I described, which is you can't find the signature of mining mercury in the environment. If you take downstream sediment samples or upstream, it's the same yarn in the same cloud. So you can't see the isotopic signature of mining mercury. Again, big system, small signal, maybe. And in the Amazon, exactly the opposite, showing exactly the opposite too. So the narrative cannot be generalized from the Amazon to the Andes. No way. Here, you see that all downstream river sediment bear the signature of mining mercury, and this goes for 300 kilometers downstream up to the Pacific Ocean. This is an area that drains to the Pacific Ocean, by the way. So, in the next slide, please. These take-home messages from the Amazon from all these years of study are very nice, but they cannot be generalized, so sorry, at least not for the Andes. So what the take-home message here is that all data showed that deforestation would be the main driver of mercury transfer from soils to rivers. This opens a virtual circle. If you want less mercury in fish, you have to start leaving the mercury where it is, which means in soil. And this requires using sustainable agriculture. Well, too bad, because the present land use policy in Brazil and so many other countries worldwide is to stimulate deforestation and mechanized agriculture, which is the opposite. issues concerning mercury and fertility. So if you are going to study the issue of mercury in fish in the Amazon, prepare to be disappointed if you are looking for the classical nice lens mercury relationship that you used to find in the Northern Hemisphere literature. In the Amazon, you have many different patterns. This classical one, the first one, you can see on the bottom left, and then you have the third one with species that simply don't bother about this issue of lens versus mercury relationship, and this second and fourth nice fellows here with a climbing ladder and a descending ladder, depending if the juveniles eat fruit and the adults eat fish, or if the age diet shift is the other way around. So try to sleep with all that noise. Next slide, please. So we have been discussing ASGM and erosion, agriculture, etc., as contributors to mercury in the environment. But everything I told to you up to now is based on what has been done in response to the gold rush from the 80s. At that time, the price of gold made a small bump, and this provoked this famous gold rush from the Amazon. What is happening now? What we see now is skyrocket high price in the gold in the international market. So you would expect ASGM to explode. And it is exploding, but we only have anecdotic evidence on that. Nobody is producing reliable monitoring data on that. Let's remember that ASGM is important, but it keeps being illegal. Though it's economically important, it's illegal. What we know for sure is that deforestation has not been too bad in the last decades. You can see a significant decrease linked basically to the better enforcement of environmental regulations. And recently, deforestation is exploding again. Next slide, please. So moving to Africa, we have a very different situation, to the point that Black, this author and colleagues in 2011, coined the term tropical African mercury anomaly. He was referring to the fact that mercury in biota in Africa have very, very surprisingly low levels, even in piscivore fish. This results in low mercury human exposure, of course, even if you have high fish consumption in some areas. So these data for fish and human are 1 to 2 orders of magnitude lower than what we just described in the Amazon. Nobody knows for sure exactly what's behind this anomaly. Next slide, please. And moving back to South America, we are good in records, positive and negative, and we have an anomaly on the other side, on the high side, but it's natural. It's in the Andes. In the Patagonian Andes, you have deep and ultra oligotrophic lakes in natural parks, so you have no mercury point sources, but you have very, very high levels of mercury in plankton and fish. I bring here you one of the many examples. You find in the literature fish around 2.5 micrograms per gram wet weight, which is quite high, and plankton up to 258 micrograms per gram. Oh, thank God it's dry weight. Okay, put it in wet weight, it will be 50. This is very, very high, and you would expect even higher levels of mercury in fish. But then this suggests there is not really having a significant biomagnification. And the clue here is that the source of mercury there would be geothermal activity, contributing basically with inorganic mercury. Next slide, please. And Australia always special. Available data on mercury in the biota show not concerning levels. Mercury in fish at or below background levels. There are many hotspots around the continent, mostly caused by mining. And very little data because these places are quite far away, expensive to go to, and because people who live there are underrepresented and indigenous Australians. The estimates on mercury deposition across Australia are equally low, which is explained by the geographic isolation, low emission, low rainfall. There was a nice official Nelson last year, which estimates roughly equivalent mercury deposition and emission. The clue here for also the low mercury biota would be ecological shorter food chains and fishing tending to feed at lower trophic level. All these conspires up to now at least to create low human exposure to mercury. Next slide, please. So some gaps, some potential gaps because there are so many others. What were the fish and human hair mercury levels in the Southern Hemisphere before colonization, ASGM, and industry? How much did these factors change or not? These parameters of fish and mercury in fish and human hair. How much of present mercury, present day mercury is legacy mercury? What to expect from now on with more exploitation, more deforestation, and especially more extreme climatic events? And the question to close, if soil erosion is a significant mercury driver, could its control be part of the Minamata Convention? Thank you for your attention, everyone. Hello?
I think we may have lost Linville, no?
We may have lost.
Thanks.
Oh, yes. Yeah, we have.
Thanks, Jean-Remy, for your contribution in terms of the biota. So just to summarize, the synthesis paper, which we are planning for the ICNGB, which will focus on mercury in the Southern Hemisphere. We will start with a section which Saul covered, which will focus on the history and legacy mercury and the importance that, and then link that into the atmosphere and also the influence the atmosphere have on water and the land and water. And then finally, there will be a section also which was covered now by Jean-Remy in terms of the biota. We are also thinking of having maybe a small section in terms of policy also, but the main focus areas will be these 4 areas which were addressed during this presentation this morning. Isako, I'm not sure if you received any questions via email or via the Twitter handle of the Minamata of the Secretariat. I did get one question for you, Jenny. One of the attendees asked, are you aware of any monitoring efforts in the Southern Hemisphere to quantify mercury fluxes and the strength of the vegetation pop? If so, in which regions of the Southern Hemisphere? That's a question I got via WhatsApp.
Thanks, Linwell. Definitely there have been some measurements of this. They tend to be quite campaign focused. I'm most aware of the measurements of the flux that have been made in Australia in recent years, as well as measurements of the deposition fluxes that have been made in the Amazon with some work from Hélène Fostier that Larissa mentioned. And there are, of course, a few wet deposition monitoring sites that I didn't have time to talk about. Of course, you know, the paper is still not yet written, so we'll be looking out for these kinds of data sets. And if people know of some that I haven't mentioned, please feel free to send them our way.
Yeah, I think that will be very helpful in terms of those that will listen after this recording again. Apologies from our side for all the technical difficulties and challenges. But if you do have any questions or comment in terms of any of the the presentation that was done today. Please feel free to contact us, especially if you know of certain papers or research that you were aware of or that you were co-author of that we don't necessarily have access to, but that focus on work that was done in the Southern Hemisphere. Please feel free to share this information with us. We know what we are attempting is quite something big, but I mean, something like this has never been done before. So at some stage, somebody needs to do it. So it's a large region that we will try and cover. We may not be able to cover all the work that was done. I think that will definitely be impossible. But if we can focus on certain key aspects in terms of research in the Southern Hemisphere on Mercury, that will definitely give researchers the opportunity to maybe write a follow-up paper in a few years' time. But I think this will definitely be the benchmark of everything that has been done in the Southern Hemisphere. And as I've mentioned, this will definitely be the first time that something like this will be tried. And I'm very confident that we will be able to pull this one off with all the great teams and all the great authors that we have at our disposal. Isako, I'm not sure, did there come any questions through for you on the email?
Thanks, Linville, and apologies from me too for the technical difficulties, and this is the first time that we experienced this, but it is very good that many people were able to join by YouTube. But we have been monitoring the Twitter and so on, but we haven't received any questions so far.
Okay, thanks for that, Isako. I'm not sure in terms of time, are we still okay, or can we still allow for a few questions, or just maybe just a general discussion for 5 minutes or something like that?
Yeah, I think 5 minutes is okay. So we will aim at closing at about 40 past noon.
Okay, so I think I'll just ask each of the presenters just a quick wrap up, and what do you think in terms of what is needed for your section to go forward and to progress? I think that will probably be the best, as I see there's only one attendee currently on the list here. So just a quick wrap up, and just some what are your ideas as how you see your section will play out for the synthesis paper. I think I will start with you, Saul.
Can you hear me? You can.
Yes, we can hear you.
Very quickly, I would say that if we can follow the trade patterns, that will be incredible. We talk a lot about legacy Mercury, and yet there isn't one single summary of where it actually ended up. And then we can go into other things. But now I think what Dr. Schneider and myself we're doing is simply following the trade.
The trade. Okay, thanks, Saul. Jenny?
Thanks, Linville. I think from the perspective of the synthesis paper, the atmosphere is quite the linking story between the legacy, the present day sources of emissions, and then what gets into the land and water. So that's roughly what we'll be aiming to focus on, is kind of linking those pictures up. In terms of what we need and what would be really useful, in particular, are research and stories about things that aren't necessarily reflected in something like the GMA. So we know where our long-term monitoring sites are. We know where some of the biggest campaigns are, but there have been a lot of unique studies in some parts of the globe, and getting some data from some of the places that we've got less sampling for will be really interesting to try to pull together in this way for the first time.
Okay, thanks for that, Jenny. Larissa?
I think that's something that really help our understanding of the not only the Southern Hemisphere's like Mercury cycle, but also for the global cycle, is the role of the Southeast Asia forests on Mercury uptake from the atmosphere and deposition, and also of Mercury from ASGN, which is really understudied, especially in the Southeast Asia area. Yeah, so I think that if we can somehow make it very clear, like make these gaps very clear in the paper and bring perspectives for future studies, you're going to be able to fill in a very important gap on the not only the Southern Hemisphere Mercury cycle, but the global cycle.
Okay, that sounds good. Jean-Remy?
Well, in terms of Mercury in the biota, we would need maybe a few hours to try to cover. But before trying to do anything new, I think it would be important to try to make a real summary of what has been done up to date, because it's quite a challenge, because it's fragments over space and time. But I remember Barbieri and Gordon made a huge, very useful review on mercury in human hair in the whole Amazon, and I think we should try to not doing exactly the same thing, but try to go the same way. Uh, because there's a lot of information, but there is very little systematization, and it's as the Amazon is the place where the concentration of mercury studies has been so high. I think it's really an important thing, and I think this paper will be a nice opportunity to tackle my bottom to go for it in time.
Yeah, okay, that's a big fish, but I'm sure we will be able to pull that one in. But then, thanks again, Larissa, Jenny, Saul, and Jean-Remy. I know this is we're only at the starting point, but I can really see there's already been a lot of effort has gone into the presentation. Probably a lot of reading as well, trying to catch up on what has been done in all the different reads. But I think as the teams will be meeting from September onwards to focus on each of the matrices, I definitely think I think more information will become available, and yeah, I'm really looking forward to how this end product will look at the end of the day. So from my side, I want to thank all of you for the presentation today. And just again, apologies. I was so excited when I heard such a lot of people were signing up and registering for the session. But unfortunately today, yeah, Murphy got us. But the presentation will be made available by the Secretariat. So as I've expressed earlier, if you have any questions or comments or papers which you know of that will be helpful for each of the presenters for their specific matrix, please reach out to them. The information will be available also on the website. And in terms of the next session for the Minamata online for the science stream, the next session will be on Wednesday, the 22nd of September, from 2:30 till 4 p.m. And the focus will be on global distribution of ASGM practices and emissions, with a specific focus on Africa, as this will also be one of the synthesis papers. So please pass this message on, share this with your contacts or researchers with vocal points. As we know from a global mercury assessment that was done in 2018, that ASGM is considered now the biggest anthropogenic source of mercury. So we hope that the team that is responsible for that that you will also register for that. Yeah, but from myself and Joy, as we are part of the executive committee for the ICGMP 2022 event, we want to thank you all. For those that was also on YouTube, thanks for making the time available despite everything. And we hope to see you at the next Minamata session on the 22nd of September. Give over to you, Isaku.
Asaki, you're
Isaku,
in.
you're muted.
Sorry. Thank you, Lin. I think you have said all I have. I wanted to say. So from the secretariat perspective, this is a very enlightening session. Currently, the Minamata Convention is a very young convention, so it focuses on addressing the current use, current emission, current releases. But as we see in the evolution of policies and scientific discussions of climate change, the land use change and so on and so forth are addressed in under UNFCCC. So I think there's an opportunity for the convention and other chemicals convention to broaden its scope. So it is very enlightening for us to listen to this discussion. We will definitely communicate with the 200 registrants about the availability of the presentation and the recording and the invitation of question comments. Thank you very much. And I think Joy may wish to say some closing remarks. Joy.
Thank you, Isaku. Thanks. I just in terms of next month's ASGM presentation. This we received also information in terms of what is being done in Africa in terms of the support that is being received from the Clean Lighting Coalition, CLIC, and they are supporting research in Africa on the amendment of Annex A of the Minamata Convention in terms, so it's a really work with NGOs and stakeholders in 13 African countries where they're focusing on understanding the national policy context, understanding the national supply chain, gathering information and availability, and then engaging Minamata focal point and government agencies. And so I think we will next month hear a lot more on that, because that basically focuses on Africa and the work that is being done in Africa, and particularly a lot being done by the NGOs. So just from my side also, Isaku, just wanted to thank you and the UNEP, the Minamata Secretariat, and everyone, your whole team that is involved in the background of it, and then also the Southern Hemisphere participants, presenters. Thank you very much for sharing the information. Obviously, there's still a lot to be done in terms of the synthesis paper. And then also, Linville, thank you from your side for facilitating this session. And and thank you everyone on the YouTube side as well for participating. And Isaku, I'm sure next month we will have everyone in the room with us. So thank you once again for everything. Thank you. You muted, Isaku?
Sorry. So now we are going to close this session. Thank you all. Thank all the presenters. Thank you all the participants. See you next time. Bye.